Hi everybody. So here we've got a past exam question in Corpio 1 on vectors. We're going to look at the equations of a line and the equation of a plane and the shortest distance between two skew lines. If you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link in the description below. So we're told that two skew lines, L1 and L2, have these equations given in parametric form. So if they're skew lines, we'll sketch L1, and I'm writing the equation in column vector form because I find that easier to handle. Now L2 is neither parallel nor does it intersect with L1. So we can imagine this line being beneath L1. So we have a vertical distance between them. So they don't intersect and they're not parallel. We need to determine a vector that is both perpendicular to L1 and L2. So we can imagine n as being a perpendicular vector passing through L2 and then carrying on to pass through L1. So we'll have a perpendicular angle with L1 and a perpendicular angle with L2. And we know the normal vector will have an x, a y, and a z component. So we need to find the values of x, y, and z. Now there's a couple of ways we could do this. If we're studying Further Pure 1, we'll learn about the cross product, and we could cross the direction vectors of L1 and L2, and this will give us x, y, and z. In Corpio 1, we need to use the scalar product. So if we dot the direction vector of L1 with the direction vector of n, then we'll get 5, 1, 0 dotted with x, y, and z. And because they intersect at 90 degrees, the dot product will be the cos of 90, which we know is 0. And now we can dot these together, so we get 5x plus y. I'm going to write 0z. We know this is 0, but I'm going to include the z term. Now I've got one equation from this scalar product. I can create another equation because we know n is also perpendicular to L2. So again, we can find the scalar product. We'll dot this direction vector with the direction vector of a normal. So we'll get 8, negative 2, 3, dotted with x, y, and z. And again, this will be because of 90, which is 0. So we'll get 8x minus 2y plus 3z. And now we've got two equations. To solve these equations simultaneously, we need to pick a suitable value that we know the normal vector will pass through. So at some point, the normal vector will pass through an x value equaling 1. I could have chosen any x value, I've just chosen 1 because it's easy. Then we can substitute this 1 into both our equations. So from L1, we'll get 5 lots of 1, which is just 5, plus y plus 0z, and that will equal 0. So therefore, y plus 0z will equal negative 5. And then from L2, if we substitute x equals 1 into here, we'll get 8 minus 2y plus 3z will equal 0. So therefore, 2y minus 3z will equal positive 8. So I've just moved these two terms over to the right-hand side. Now I can solve these two simultaneous equations on my calculator. And when I do this, I get y equals negative 5 and z will equal negative 6. And we know that x is positive 1. So the normal vector will be 1i minus 5j minus 6k. Okay? So that's how you work out the normal vector using the scalar product. In part B, we need to determine the equation of a plane that's parallel to L1 and contains L2. And we need to write it in the scalar product form and the dot product form. So I'm just going to write this n as part of our diagram here. So I'm just going to show a plane that runs parallel to L1 but contains L2. And we'll call this plane pi. To find the equation of a parametric form, we need a position vector and two direction vectors. Now, if the plane contains L2, and this is a point on L2, this will also be a point on the plane. So the position vector, this A term, would be 2, -4, and +4. Then we'll have a multiple of a direction vector, and again, if L2 is on the plane, then this will be one of the direction vectors. So we'll have S multiplied by 8, -2, +3. And we're told that the plane runs parallel to L1, so this will be the second direction vector. So we'll have the multiple T, and the C term will be 510. Okay? This is the parametric form. For the dot product form, we know this n is the normal vector, which is what we've worked out here. So we'll have R dotted with the normal vector, 1, -5, -6, will give us some constant P. This R is any position on that plane. Well, we know this must be a point on the plane. So we can substitute this point from L2 into the point R. So we'll have 2, -4, 4. I'll just move this over here. Dotted with the normal vector. And this will allow us to work out P, the constant. So P will be 2, -4 times -5 will give us +20. And 4 times -6 will give us -24. So P will equal -2. So the scalar product will be R dotted with the normal vector, and that will give us the constant -2. Okay, so that's part B, the parametric form, the scalar product form. In part C, determine the shortest distance between L1 and L2, giving our answer in the simplest form. So we know that L1 runs parallel and above L2 because L1 and L2 are skew lines. So if we look at this two-dimensionally, we've got the plane, I'll label this as pi, and then running above and parallel to the plane, we've got the line L1. Now because L1 is parallel to pi, any point from L1, its distance, its shortest distance to the plane would be the same as any other point. And we've been given this point on L1. So we can label this here. We'll have a point 1, 2, and -5. Now what we need is the shortest distance, the perpendicular distance from L1 to pi. So I'll label that here, where these are both right angles. And now we can just use the standard formula given in the formula booklet because we've got a point and we've got a plane. So in the EdXL formula booklet, we're given the perpendicular distance from a point to a plane is this formula. So I'll copy and paste this into the notebook. This N1, N2, and N3 are the I, J, and K components of a normal vector. So N1 will be 1, N2 will be -5, and N3 will be -6. The alpha, beta, and gamma are the x, y, and z coordinates from a point on the line we're trying to find the distance to. So alpha will be 1, beta will be 2, gamma will be -5. And to work out d, we need to move this over to the other side, and when this d becomes +2. We'll substitute them all into here. So the shortest distance will be n1 times alpha plus n2 times beta plus n3 multiplied by gamma, plus that +2. And we want to take the magnitude of this. And this is divided by the square root of n1 squared plus n2 squared plus n3 squared. So we can work this out on our calculators, and we get 23 over the square root of 62. In its simplest form, we need to rationalize this denominator, and this becomes 23 root 62 over 62. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can find all the lessons on vectors for Core Pure 1 on my website, mrmathematics.com. I'll leave a link in the description below.